Machine translation.
Hello, it's time to tell you what the heating elements of Teplel for heating convectors are made of. This is an ordinary Shungite, not elite and not grey. It is an ordinary black mineral. Only it is suitable for the manufacture of a heating element due to the suitable carbon content in the quartzite matrix. Shungite can produce microvolts of energy if a saline solution is dropped on it. When heated above 150 degrees, the resistance in Shungite decreases. Therefore, superconductivity can occur not only at sub-zero temperatures, but also when heated. The production is simple. You buy Shungite plates with a thickness of 7 mm, 3 mm or bricks and mix them on a stone cutting machine, measuring 10 by 10 mm. Why exactly these sizes? Because they are the most suitable for this purpose of Shungite. Thin 3 mm thick are well suited for non-ferrous metal, 7 mm for steel. Of course, it is possible to use 7 mm thick for non-ferrous metals, but this is not economical. Seven mm steel tubes must be enclosed in a heat jacket, so less energy is consumed and more metal is heated. A sealant for furnaces is used as a heat jacket. You can add microfiber and quartz sand. As I have already shown, the convector is assembled by stringing sections from a profiled tube onto insulated studs. Elements are placed between the sections and pressed well. On aluminum sections, it is advisable to place the elements on a copper foil made with a profile bracket. This improves electrical contact, which reduces energy consumption for aluminum oxide film breakdown. If you are going to use punched water sections of aluminum convectors, then elements with a thickness of 7 mm should be installed on such a volume of metal. The power supply is low voltage, but with a high current. Switching power supplies have proven themselves well as a power source. It is better to take it with current and voltage regulation. It can be connected in parallel, but with a power supply of up to 5 to 6 volts, inconsistently at 12 to 24 volts, and inconsistently in parallel. Supply power with a thick enough wire and cover the convector with a screen. Convectors can be of any size. I think it will be possible to use the elements to heat the water. I made another type of Shungite element, but this option is costly and capricious. It consists of Shungite powder with a specific liquid, of which only 2 are suitable. A small piece of this mixture is applied to a metal plate and pressed with another plate. This option operates from 12 to 220 volts and has good heating. This element also fits between the sections of the convector and is pressed down. The clamping force regulates the passage of currents and voltage. Overheating above 200 degrees leads to degradation of the element. That is, the liquid dries up. Now you can check the effectiveness of such convectors yourself.